5.3, Graphing through Transformations. So the last few days we've been graphing parabolas in mostly the same kind of manner. We found the vertex, make it graph by making a table with the vertex in the middle. We can also graph what we call here through transformations, and that is by looking at what's different from ours relative to a parent function. And the parent function that we would compare it to would just be x squared. So keep in mind that we've dealt with x squared enough at this point. So hopefully, if I draw a quick little sketch here for x squared, you would be familiar with that. So x squared will look like this, goes through 0, 0, then 1, 1, negative 1, 1, and at 2 would be at 3, sorry, 2, 3 would be at 4 already, and at a negative 2 would be at a negative 4. And so that's a picture that you're pretty familiar with. Okay? The way then to do graphing through transformations would be by figuring out what is different from y equals x squared, and y equals x squared can be written this way. So the short way is this one, but y equals x squared can also be written as 1 times x minus 0 squared plus 0. So the easiest way to do these is actually by comparing it to the vertex form of our parabola. Okay, and we've looked at this a bunch in terms of what kind of changes occur and what happens over here. Sorry, I'm trying to find my notes. So I got them. Okay, so how does the graph change when you use difference values for a, h, and k? Okay, so let's actually mark. So here is what a normal parabola looks like. So for example, if I only change one thing, if I say, well, let's make that a plus, let's actually do it this way, an x minus 3 squared plus 0. Okay, what changed? Well, h, now keep in mind that if it says a negative 3, it's a 3. So h is actually 3. So that means that it moved over to the right 3 units. So 1, 2, 3. So the vertex that used to be at 0, 0 is now at 3, 0. Well, then the next dot, 1 to the right, should still be 1 up. 1 to the left should be still 1 up. And if you go 2 to the right, it should be up 4. And 2 to the left should be up 4. So this is what the graph should look like for y equals 1 times x minus 3. So that's just x minus 3 squared plus 0. So x minus 3 squared, like this, looks like that. What if we change a little bit more? So what if we actually looked at, well, what if it was y equals a negative x minus 3 squared plus 0? So that would be a negative 1, right? Well, then the h, being a 3, still moves it right 3 units. Okay, so that's actually, I should have written that over here. That's the actual transformation that occurred. So the actual transformation is what happened relative to y equals x squared. Okay, so the 3 here would be right 3 units. And so the only other thing then that we have left is if I just say right 3 units, I would still be at x minus 3 squared plus 0. Okay, and then the negative 1, a negative here, a negative 1 makes it flip across the x-axis. Or we could say it means it goes down at the normal rate. Now, I'll show you both. So flipping across means that this dot actually mirrors over here, and this dot would mirror over here. So that's if you do flipping, if you think of this as a flip. If you say down at the normal rate, that means that instead of going 1 to the right, up 1, if you go 1 to the right, you should go down 1. And the following dot, so to the right 2 and up 4 would be to the right 2 and down 4. So they do the same thing, and at some point, we probably should look at, are they really the same or are they different? And then we may actually do that in pre-cal. And but initially, let's just worry about what the pictures look like. Okay, so that would be a parabola that has two transformations. So if I was listing the transformations, so plus 0, which probably would be given to you this way, I would say, okay, well, we started with, so compared to x squared, okay, I can make that x minus 3 squared by doing right 3 units. And then I can make it a negative x minus 3 squared, and then pick either one of these, flip across the x-axis or down at the normal rate. And actually I'm going to say down at the normal rate for right now. Okay, I want to put one more thing there for normal rate. So the normal rate is what happens here. So the normal rate for a parabola, if I just look at the parabola, what happens? So at 0, I'm at 0. If I go 1 to the right, I'm up 1. If I go 2 to the right, I'm up 4. If I would go 3 to the right, I'm up 9. So the normal rate, you could do it the way that I just did it. 1 to the right, up 1. 2 to the right, up 4. 3 to the right, up 9. You can also say, well, the first increase is add 1 to the y, then add 3 to the y, then add 5 to the y, because remember we talked about this pattern. So the next one should be up 7. So let's see, 4, 9 plus 7 is 16. So you could say 4 over 16 up, or after the third dot you would go up another 7. So let's see if we can do that a little bit, if we can use the plus 1, the plus 3, and the plus 5s. So our new vertex is here, so we're going to go down. So instead of up 1, it's the normal rate, it's down 1. And the next dot should be down 1, 2, 3. And the next dot should be over 1 down 1, 2, 3, 4, 5. So did that work? So that's 3, so this should be 9, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that worked. Okay? So the last transformation that we'll look at then is what happens if I also transform it with k. So we'll use gray for this, and let's do it 2. And so to give ourselves some room, instead of going right 3, we'll go left 3, and then we'll go up. Now let's do that one down. Say minus 4. Okay. So we have 3 transformations here. We have a plus 3, that's different from the 0. We have a minus 4, that's different from, so that's 0, and that's 0, and the 1 changed into a 2. So a normal parabola looks like this. The plus 3. Yeah, actually I'm going to do the 2 first. So to make that into a y equals a 2x squared, that means that instead of going up 1, I should be up 2. So I haven't changed the vertex yet. And so instead of going up 4, I should be up at 8. Or if I say the normal increase is plus 1, the normal increase is plus 3, then from here the increase is twice as much, so it's plus 6. So plus 1, 2, 3, 4, 5, 6. Plus 1, 2, 3, 4. Sorry, plus 1, 2, 3, 4, 5, 6. So I missed the dot over here, didn't I? Let's go back. What's going on there? There. So we are at 2 and need to go up 1, 2, 3, 4, 5, 6. And then here up 1, 2, 3, 4, 5, 6. Now it matches. So that's what y equals 2x squared would look like. And then we can make this. So this was twice as fast, right? So this is still up twice as fast. That's the transformation. So then we can do, well, what if I make it an x plus 3 squared? So the plus 3 is actually if you had think of that as an x minus and -3. So that's actually 3 units to the left, because negative's to the left. So that means that the vertex moved 1, 2, 3 units left. So this moved 1, 2, 3 units left, and this moved 1, 2, 3 units left. And this one moved 1, 2, 3 units left, and this one also did 1, 2, 3 units left. So that's the new parabola. So I'm almost there. So that would be 2x plus 3 squared. And then the last transformation is that -4. So to make it a 2x plus 3 squared minus 4, this -4 means that we need to go down 4 units. So down 4 units. So 1, 2, 3, 4. Let's do that with x's. So 1, 2, 3 down 4. 1, 2, 3 down 4. 1, 2, 3, 4 down. And then here 1, 2, 3, 4 down. And this one was down 1, 2, 3, 4 down. And so then finally we get our parabola through the x's. Sorry, traveling to the left, right a little bit. And it looks like this. Sorry about the mess there. Usually I don't graph all the transformations, I just wanted you to sort of see them. Okay. So here's a summary. So if a is between 0 and 1, it's still positive, right? So both of these are still positive. So if a, then it does still go up. But if it's between 0 and 1, so for example, if it was a half x squared, then it goes up half as fast as the normal rate. Keep in mind that the normal rate was, if we started at our vertex, the next dot was at +1, then at +3, then at +5. So these are the y values. So the y values will be up by +1/2, by +3/2, and +5/2. If a is greater than 1, that's still positive, so we're still going to go up. For example, if we said y equals 4x squared, then we go up don't know what just happened. I held the marker somewhere wrong. Then we go up 4 times as fast as the normal rate. And again, if the normal rate was +1, +3, and +5, then actually now we're going to go from the vertex. The next dot will be up 4, and then it will be up 4 times 3 is 12. And then the next dot after that, 4 times 5 is up 20. Let's check that. So the vertex would still be at 0, 0 here, and at 1, you would be 1 squared is 1 times 4 is 4. At 2, you do the 2 squared first. 2 squared is 4, and 4 times 4 is 16. So do we get +4 and +12? And we do. Okay? So for the negatives, if it's between the -1 and 0, again that would be something like this, and -1/2 x squared, then it would be down, in this case, half as fast as the normal rate. And if it's less than a -1, for example, y equals -4x squared, then the y values will be down and then 4 times as fast as the normal rate. Okay, most of this is review, so we've done this before, right? H is a shift right or left. So x minus 3 squared would be 3 right, because it would just be the positive 3, whereas if I wrote x plus 3 squared, it would be 3 to the left, because it would be a negative 3 that we'd have here. So that one's backwards. And then k is a shift up or down. So it's only a shift up or down in the y's. So for example, an x squared plus 5 would be up 5 units. Right? So for example, the vertex wouldn't be at 0, 0, it would be at 0, 5. The next one wouldn't be at 1, 1, it would be 1, 6, because you would still go up 1 only from here. And the next one would be up 3, so at 2 you would be at 9. If it was y equals x squared minus 12, then that would be down 12 units. So if you look at your xy table here, normally the vertex is at 0, 0, here it would be at a 0, negative 12. And then at 1, you would say, well, plus 1, you would be at a negative 11, and then plus 3, so at 2, you would be at a negative 8. And you can check that, because 2 squared minus 12 better be a negative 8. Okay, so that seems to be working. Alright, so let's do some examples where it says list the transformations and graph the parabola. Okay, so I'm going to pair this to y equals x squared. So to make it a y equals 3 x squared, I'll say that it is up, because it's positive, up 3 times as fast. To make it a x minus 2 squared, after we've already taken care of the 3, then we will say, well, it's right, because that's a negative 2, so that's actually positive, right, 2 units. So the vertex is going to shift 2 units to the right. And then to make it x minus 2, 3 times x minus 2, sorry, minus 6, we're going to say that we also need to go down 6 units. So the vertex is going to shift 2 units to the right and 6 units down. Okay. So the vertex shifts 6 units down, and I need to give myself some room to graph some negatives, don't I? Because the vertex is supposed to be here at 0, 0, and it's not going to be there anymore. So it's 2 units to the right. So the vertex used to be over here. Now it's going to go 2 units to the right, and it's going to go 1, 2, 3, 4, 5, 6. So that's the new vertex. So notice I still graph the vertex first. So I'm doing this sort of actually backwards now when I graph it. Then it says 3 times as fast. So keep in mind that the normal x squared, so I actually do it this way. So this is what's going on in my head. My normal x squared at 1 would be at 1, at 2 would be at 4, and at 3 would be at 9. So it's up by 1, up by 3, up by 5. It says 3 times as fast. So the next dot over 1 should be not up 1, but up 3. So we're up 1, 2, 3. I wish I had better graphing paper here. So symmetry does work still over here. So there's a dot over here. And the next dot isn't over, the next one to the right isn't only up 5, it's up 15. And up 15 is, you know, and I only have 1, 2, 3 units left, and then it's another 12 there. So it's really steep, so I can't graph it. It'd be way over here. But I do know then that, you know, if I go up that fast, that I know for sure I'm going to cross between this one and the next one over, between this one and the next one over. So even though I don't know for sure what my x-intercepts are, because we could solve for it, I do know that it occurs between, let's see, that's 2, 3, between 3 and 4, and between 0 and 1. So that's a pretty good graph. Okay, how about this one? So again, comparing it to y equals x squared. So if I compare that, then the negative half x squared, it means it's down half as fast. Or, yeah, half as fast. Sorry, slow a little bit today. And then I can make it shift, so the plus 4 actually be, that counts as a negative 4, so that's left 4 units. So now I'm talking about the vertex shifts to the left 4 units, and then the plus 5, so to make it an x plus 4 squared plus 5, I need to shift my vertex up 4 units. Okay, so I'm ready to graph. So we went left 4, so I need some x values here. Up 5, but the whole thing goes down, so I don't need super large positive y values, but I do need to give myself some room. So I did it again. So let's see. So left 4. Did I give myself enough room? So 1, 2, 3, 4. Why did I write 4 units there when I clearly said 5? That's 4, and 1, 2, 3, 4, 5. So left 4, up 5. So my vertex will be here. And then down half is fast. So sometimes it helps a little bit here. So 0, 0, 1, 1, 2, 4, and at 3 would be 9, and at 4 you'd be 16. Okay, so the next dot should be only a half up, right? And then the next dot here should be 3.5. So from 0 to 4 is actually an even change. So what I'm trying to say is this. So let's ignore these. So if I go 2 dots to the right, so if I go 2 to the right, I should go up 4 up. That's going to be down, but it's half as fast. So 2 units to the right, 2 units to the right, and I'll only be down 1. Not 4 down, but I'll be down 2. So that would be over here, down 2. That needs to be a little bit lower. This is why I need graphing paper. So that's 1, that's 2, that's 3, that's 4. So 2, and I'm over 1. 2 over and down 1, 2. So I should be here. That means the symmetry does occur over here. So once you have that one, this one's a little bit easier. So that's 1. And then, so let's see, 3 units would be 9, so that doesn't help. But if I go 4 to the right, my normal parabola would have been up 16, up, so I can go up by 8, but I need to flip it because I'm actually going down. So if I go 4 to the right, so 1, 2, 3, 4 to the right, I'm actually right here on the axis, that helps. I should be 8 down. So this was 5 down, so this is 6, then that's 7, and that's 8. So I actually got an intercept over here, and that's good. So then symmetry tells me that if I go 2 more this way, it should be about there. So then my parabola looks this way. That's something over there. Alright, that's as good as it's going to get for me today without graphing paper. Okay, thank you.